In this video, we will review the main functionalities introduced with the release of version 1.11. Anomaly Detection and Fixing. The first feature in this release addresses anomalies. Anomalies are distortions on the surface of a 3D object that can cause issues during deformation or printing. These distortions need to be fixed to ensure smooth workflows. To fix them, simply click on the red element of the control. This action removes the distorted surface and replaces it with the blue element, effectively repairing the anomaly. The software highlights all distorted surfaces for easy identification. If there's a specific area you don't want to fix, you can choose to skip it. Supernumerary teeth. Next, we'll move on to the bolt-in analysis. In this feature, the software automatically identifies and marks all 32 teeth of the patient. However, in this case, we notice supernumerary teeth. These additional teeth can be manually accounted for in the analysis. For example, we see a supernumerary tooth between teeth 15 and 16. To account for it, select tooth 15. Add a supernumerary tooth on the distal side. Confirm the addition by placing the T mark. I will repeat this process for tooth 25. Now, the software recognizes that this patient has 2 supernumerary teeth, in addition to the standard 32 teeth. These extra teeth will be included in subsequent scenes, such as segmentation, tooth orientation, and setup, where the same manipulations will apply. Segmentation. Let's move on to the segmentation scene. In this step, segmentation contours are generated automatically. Let me check the contours for the supernumerary teeth. The contours were well built and did not require any additional adjustments. Tooth orientation. Next, we'll proceed to the tooth orientation scene. During the root stage, if CT-based roots are used, the roots for the supernumerary teeth will also be calculated. If parametric roots are used, you can edit the root direction for the supernumerary teeth in the same way as for the primary teeth. Retainers. Finally, let's transition to the setup scene. Here, I'd like to introduce the new functionality for retainers. This feature is especially useful for cases where treatment is unnecessary, where scans have been loaded, but no tooth movement, attachments, or other interventions are required. In such cases, we can now add retainers. To do this, we'll select the 0 line and choose between a passive line or a retainer. In this example, I'm adding a retainer, which is indicated by the R marker on the timeline. Toolset. Next, let's look at a design improvement, the toolset. This tool provides a graphical visualization of tooth position changes, complementing the numerical data available in the matrix. In addition to visualizing changes, the toolset allows for manual adjustments. For example, you can manipulate the rotation center. This point represents the center of resistance, the center of rotation, or the center of the gizmo. The 3D control element for tooth movement is initially positioned at the center of the crown. You can also use rotation centers at the hinge, mesial, and distal points. We've also added 2 additional points. Tip of the crown. Tip of the root. The point where the gizmo is attached directly impacts the movement mechanics of the tooth. Similarly, in the tooth movement table, there's a feature called the reference point. This point can be adjusted to one of 4 positions. The reference point is essential for determining how displacements are calculated. Hard movement limits. Another important feature in the tooth movement table is the ability to set hard movement limits. These limits allow you to define thresholds for tooth movement, either for each tooth individually or for all teeth collectively. It's important to note that these limits don't restrict movement but instead set parameters for controlled adjustments. For instance, if I want to highlight extrusion/intrusion values exceeding 0.7 in red within the matrix, I can set this limit. The tooth can still move beyond this value, but the highlight serves as a visual alert. Now, as you can see, when the value exceeds 0.7, it is highlighted in red. The limits can function either for individual teeth or for all teeth simultaneously. Additionally, in the matrix, you'll notice rows corresponding to each supernumerary tooth. When a tooth is moved, the corresponding values are dynamically displayed. Retainers and passive aligners. Let's now focus on retainers, as well as passive aligners. To begin, we'll open the treatment plan and expand it slightly. Let's assume that after the second aligner, I'd like this patient to have 3 passive aligners. To do this, we select the second aligner and add 3 passive aligners. You'll notice the number 3 displayed here, which confirms that 3 passive aligners have been added. This information will also be reflected in the PDF document that's generated for export. Similarly, for the final aligner, we can add a retainer. Additionally, we've made improvements to several features, including keypoint interactions, group selection and single selection, and the control elements for managing attachments, bite ramps, elastics, and pontics. Auto setup. Now, let's move on to the more advanced functionalities, specifically auto setup. For auto setup, options such as F8 profile and no profile have been added. Let's discuss the no profile torque and no profile translation options and how they differ. The key difference lies in the prioritization of movements. No profile torque primarily affects torque angulation. No profile translation focuses on translational movement. A similar distinction applies to F8 torque and F8 translation, with one additional factor. The F8 profile includes angle change profiles on the rod. These profiles represent a new and experimental feature in our software. As we continue developing this functionality, we will collect feedback to refine it further. Despite these updates, the mechanics of working with this tool remain unchanged. For example, first, we extend the arch. Then, we click Move Teeth. You'll observe the teeth shifting to align with the new arch. This enhancement provides greater precision and flexibility while maintaining a familiar workflow for users. Jaw displacement updates. The latest updates in the setup focus on the jaw displacement functionality. While the changes to the virtual articulator are minor, they address one of the most frequently requested improvements. We've adjusted the speed of the lower jaw's movement relative to the upper jaw. Additionally, we've enhanced occlusion handling. And jaw displacement functionality now supports backward movement, introducing full compatibility with Class 3 occlusion. As before, in the final position, you can clearly observe the resulting changes. Post-processing scene updates. Moving to the post-processing scene, the key update here is the introduction of scaling for fillers in 3D space. Previously, you could only modify fillers through the context menu. Now, this can be done directly using a 3D element, providing a more intuitive and streamlined workflow. Matching and refinement updates. Let's assume you've completed a case, but midway through treatment, the patient requires additional scans for matching or refinement. Here's what's new. Matching enhancements. During segmentation of a new SDL scan, you can now view the base case tooth map. This allows you to compare the tooth setup from the original case with the new scans. For example, here we can see that certain teeth were present in the original case but are now missing in the new scan. This confirms that the teeth were likely extracted during treatment. Mismatch detection. After loading the matching scan, you can check for mismatches in tooth alignment relative to the target positions. For instance, on aligner 3, we can see some areas that haven't reached their intended placement. You can also use the overlay feature to visualize discrepancies. This is part of the existing. Now, let's move on to the improvements in refined treatment. You can now specify which surfaces to use in the refinement process. For instance, choose surfaces from the original scan. Or, select surfaces from the newly uploaded scan. This is especially useful if a tooth has been treated or modified in shape. You can let the software know which version of the surface should be used moving forward. For this example, I'll choose Refine and select all tooth surfaces from the new scan. Starting from aligner 3, we can now adjust the treatment plan accordingly. That concludes the updates in the Vision application for Release 1.11. Thank you for watching.